Okay, we're going to some problems in this lecture in type of, since we just did factoring of trinomials or quadratic expressions, nothing but 1 in front of x squared. Let's do these that have something other than 1 in front of x squared. Now recall when we were factoring the ones that just had 1 in front of x squared, we made our two sets of parentheses, except I can't type. And we put x and x in the first position. And we are going to have an x and an x, but we've got to deal with this coefficient right here. So we have to think factors of 6. So we could have a 2 and a 3, or we could have 1 and 6. And it's wise to kind of start with the ones that are kind of the most common to us. So 2x and 3x will multiply to give us 6x squared. Now what we're going to do is something called trial and error. So I want you to notice first of all that there was no greatest common factor in all of these terms. There was nothing that we could pull out. So that's important. So as we get ready to find factors of negative 15, well, of course, the first thing that comes to mind is 5 and 3, and we need one that's negative and one that's positive. I don't want to put the 3 together with that 3 right there because that would create a greatest common factor in this parentheses. So I want to put the 5 over here. This time I'll make the 5 negative. It might be the wrong choice, but this is trial and error. So we'll make the 5 negative and the 3 positive, and we'll see what we get. We need for our two middle terms to add up to negative x. Now what we do is we've got to check the outside and the inside multiplication. So I'm going to check the 3 times 3x, that's 9x. Can't draw very well with my mouse. That's supposed to be a 9. All right, and then 2x times negative 5x. 2x times negative 5 is negative 10x. All right, now 9x added to negative 10x gives us negative x. This was the right choice. So we have this factored, 2x plus 3 and 3x minus 5. Now let's go to the next one. Let me get out of the draw feature here. Let's do the same idea. Two sets of parentheses. 12x squared, but we could have 3 and 4 or 2 and 6 or even 1 and 12. The one we tend to think of the most is 3 and 4, so let's do that one first. It may not be the right choice, but we'll find out. All right, now negative 14. That means I need a negative and a positive. First thing we think of with 14 is 2 and 7. Now let's notice if I put a 2 in here, I would get a greatest common factor with that 4. So the 2 needs to go over here. I'm going to make the 2 negative, and I'll make the 7 positive. And let's check this. Again, I'll just use our little draw feature. We're going to do the inside. Negative 2 times 4 is negative 8x. And 3x times 7 is 21x. Notice negative 8x added to 21x will give us a positive 13x, and we need a negative. Well, this is kind of an easy circumstance to fix. If this is the opposite of what we want it to be, all we need to do is change our signs. So, in other words, all I need to do is change this one to the plus and this one to the minus. And minus. And what that does is it changes our 8x to a plus and our 21x to a minus, and now we have exactly what we need to get the negative 13x. All right, so let's go to the next one. Get out of the draw again. All right. Okay, so 16x squared, we could have several choices. We could do 4 and 4 to get 16. We could do 2 and 8 to get 16, or we could do 1 and 16. The one that we think of the most often is 4x and 4x. I have a feeling that's not our answer, but we'll go ahead and start with that just so we can see the trial and error process. All right, now 15, we normally think of 3 and 5. We need it to add to negatives though, so that really means we need a -3 and a -5. So let's put both of those there, and let's check it. So if I check the inside, this will be -12x. I am so bad at drawing on this thing. All right, and if we check the outside, that will be -20x, and that adds to -32, which is not -46. So something is a bad choice. My guess is it's the 4x and the 4x. I think probably 3 and 5 are fine. So I could be wrong though. We may have to change those. Let's change. I'm going to go out here and make a second attempt. And instead of 4 and 4, I'm going to try 2 and 8. And I'll go ahead and keep the -3 and the -5 the same. We might have to switch their positions because switching their positions will lead us to something different. But let's double check now, see what we've got. So inside, now you notice I didn't switch the positions in the last one because 4 and 4, if we switch their position, will be exactly the same. So -24x is our middle. Let's see what we get from the outside. That is -10x. And that too does not add up to -46. Now I can switch either the 2 and the 8 or the -3 and the -5. I've got to make sure though that I only switch the first with the first or the last with the last. I don't want to mix those up. All right, so I'll switch the last. So I'll keep my 2x and my 8 in the same spot, but I'll switch the 5 to the front and the 3 to the back. And then let's check. And you see, this is why it's called trial and error, because we fool around until we find the proper combination. So -5 times 8x will be 40. And 2x, sorry about my dog in the background, times -3 will be -6x. And let's notice that -40 and -6 does give us the -46x that we need. This last one is the right combination. All right, so let's go to our last one here, and then we'll go up to that other type of problem. Get out of the draw feature. All right, so doesn't want to go down here. Okay, parenthesis and parenthesis. There's only one choice for 2x squared. It has to be 2x and x. So that makes that a little bit easy. But there's lots of choices for 36. So we could have 6 and 6. We could have 4 and 9. We could have 3 and 12. We could have 1 and 36. So let's try 3 and 9 are usually, or rather 4 and 9 are usually the ones that we think of first, or 6 and 6. So we don't want to put the 4 here with the 2. That would cause a greatest common factor. And we need one negative and one positive. So I'm going to put a 4 there and a +9 here. And let's see what we get. Again, I'll use my draw to check. 9 times x will give us 9x. And then on the outside, 2 times -4 will give us -8x. Now let's notice that 9x and -8x add to a positive x. We need a negative x. And remember what I said before, all we have to do in that instance is change our signs. So this becomes negative, this becomes, positive, which in turn changes this to a -9, this to a +8, and that does add to our negative x in the middle. All right, now let's go back to the ones that I skipped. We're going to factor these. Just like the others, they're going to have 2 sets of parentheses. But notice here there's no middle term. These give themselves away. They're differences of squares. Both of these numbers and the first term are perfect squares. You'll notice x squared is x times x. 16 is 4 times 4. So they're perfect squares. So what we're going to do for perfect squares, once we recognize we have a difference of squares, we make our two parentheses. We say square root of x squared. Well, that's x. We'll have x and x just like we normally do. Square root of 16 is 4. So we'll have 4 and 4. But in order for the middle term to cancel out, we have to have one that's negative and one that's positive. And order doesn't matter as long as we have one of each, a negative and a positive. So let's look at the next one. Again, we see it's a difference of squares. We have two perfect squares with a minus sign in between. So we need an x and x. Square root of 49 will be 7, so we need, and notice this time, just to be different, I'll put the plus first and the minus second. It doesn't matter. All right, well, again, let's notice two perfect squares with a minus sign in between. Well, again, x and x. And then our square root of 81 is 9. And we need one of each sign. So it doesn't matter, plus and minus. All right, now I put that last one in because it's very important. You'll notice that every single one of these had a minus sign in between. If we have two perfect squares with a plus sign in between and no greatest common factor between the two of them, this thing, on the other hand, is prime. We've got to have that minus sign in order to make those two middle terms cancel out. So this one is prime.